Hi, everyone. So this is, I believe, the third lecture regarding the discrete time Markov chain, right? Is that right? Third lecture. Okay, so today I'm going to give you another example. So using this example, we're going to practice how to model Markov chain model, right? Of course, the very first step is we're going to deal with how to define the state of system, which will be used for Markov chain modeling. Okay, so this is the one. Okay, so let me give you like about 5 minutes. Why don't you read through the problem description and then think about how you can define the state of system. So how do you define the state of system?
Have like three.
Three? How? How did you define?
0 year, 1 year, and second by year.
What about accident or not accident? Accident or no accident? That'll be more intuitive, right? I'd go with accident or no accident.
For accident in 1 year.
Yeah. 1 year, something, yeah. So there are several different ways you can define. But I'm going to show you in this example probably 2 different ways. And then you can compare which way would be better. Okay? It's up to you. I'm not going to say, okay, the first methodology is better than the second one, or other way. It's up to you. Okay? But I believe intuitively you can define 2 different states. Because the major concern of this problem, insurance company, is whether their customer has a car accident record or not, right? So I would define 2 different states of system. The first one is there is a car accident record. And then second state is there is no car accident record. Okay? So let me. Okay. Let me open this up. Okay, so I'm going to define first state is, let's say, there is an extent, okay? And then there is no extent, okay? So we have two different states. And according to the problem description, what is the transition probability from extent to extent? Of course, in this case, each transition takes 1 year. That is our assumption, okay? And what is this probability? Let's say a customer who has had an accident during the last year has a 10% chance of having an accident during the current year, right? So this is going to be 0.1, is that right? Which means, what is this probability? They're going to have no accident. That's going to be 1 minus 0.1, which is 0.9, right? Then what about this probability? The problem description, if he or she has not had an accident during the last year, there is only a 3% chance of having an accident during the current year. So this is going to be 0.03. Is that right? And this is going to be 1 minus 0.03, which is 0.97. Is that correct? Right? So obviously, one step or one stage transition probability matrix can be obtained like this: accident, no accident. And that's going to be 0.1, 0.9, 0.03, 0.97. Is that correct? Okay, now let's try to get the limiting probabilities, the steady state distribution. Do you remember what formula we're going to use? We're going to use pi equals pi p in the matrix form, right? And then summation of every pi is going to be 1. So that's what you're going to use, right? So here, pi 1, pi 2 equals pi 1, pi 2 times this P matrix, right? So here, we have pi 1 equals pi times the first column of this P matrix. So it's going to be 0.1 pi 1, 0.03 pi 2. Likewise, pi 2 equals pi times the second column of this P matrix. So it's going to be 0.9 pi 1, 0.97 pi 2. And you remember, this system of linear equations are linearly dependent, right? So what you need is take out one of these equations. So just randomly, just arbitrarily, I'm going to choose one and take this out. And then I'm going to add another equation, right? So let's say these are equation 1, and these are equation number 2. Then I can rewrite the equation number 1. I'm going to move everything on the right-hand side in the equation number 1 to the left-hand side. Then we are going to have 0.9 pi 1. No, actually I can leave pi 2 terms on the right-hand side. So I have 0.03 pi 2, right? So I have, what is that? 30 pi 1 equals pi 2. Is that right? So let's say this is 1 prime. Okay? And then I use this 1 prime to 2. Then what do we have? I'm going to have 31 pi 1 equals 1, right? So pi 1 should be 1 over 31. Is that right? Can you give me the number? What is this? 0.032. Thank you. So pi 2 is very easy. It's 30 over 31, right? It's going to be 0.968, right? Something like that. Okay. Now, what you want is, okay, the question is during a typical year, what is the average premium paid by an all-city customer? How do you get the premium value of each customer? You're going to use these values, right? The insurance company will charge $100 to the customer who has no accident record during the past 2 years, right? And then they're going to charge $400 to the customer who has an accident record for each of the last 2 years, and then $300 to the customer who has only one accident record during the last 2 years. So we're going to use this value, right? So let me write down here expected cost per each period, right? That's going to be what? So we have to multiply some value here times $100, right? And then you're going to multiply something to $400. And then also you're going to multiply something here times $300. Then you're going to get expected premiums, right? Okay, so my question is, what do you need each of this?
No accident.
Right. Here, we're going to put the probability that the customer has no car accident record for the last 2 years, right? Then how'd you get this? Somehow we need to use these steady state probabilities, right? Is that going to be enough? What about this one-step transition probability matrix as well? Think about this. Okay, what about this? I'm going to put pi 2 times p sub 2. How about this? What does this mean? What is pi 2? Pi 2 means after a long period of time, like let's say 100, even 1,000 years later, we're assuming that the state of the system becomes very stable, okay? So after a very long period of time, when you check your customer's accident history, about 96.77%, which is pi 2, okay? About 96.77% of your customers has no car accident history. Is that correct? Okay? And then you multiply by P sub 2. What is P sub 2? It will say all of these customers who has no car accident history will have no car accident in the following year. Is that right? With this probability. Is that correct? Because here, P sub 2 is this value. It starts from no accident this year, or certain time, or certain point in time, and then after 1 year, customer has no accident again. Okay? So if you multiply pi 2 times P sub 2, and then multiply $100, then it makes sense. Okay? Because this shows that your customer has no car accident record for 2 years. Is that right? In consecutive years, 2 years. So for those customers, insurance company will charge $100 a premium. Is that right? Then how do you get this value? Very similarly. How do you get this? You're going to charge $400 to the customer who has 2 accident record, right? So that's going to be pi 1 times what? P11, exactly. Does that make sense? Okay. So after a long period of time, when you check the customer's accident record, he has a car accident. Okay. And then by multiplying P sub 11, it shows that the following year, he again has a car accident. So for those of these customers, the insurance company will charge $400 a premium value. Okay? So this should go in there. Then what about this? Could you say that again? P12
and P21.
P21?
Yes.
What about pi? What is pi?
Of course, including the pi. But
How?
I'm trying to figure out like one probability that's including either the 1 year or the second year. So
right.
the distance has become one of the years. So.
Right. So how do you include pi values? Limiting probabilities. It's very similar to this,
Yeah,
right?
Yeah.
How do you multiply? Let's start from pi 1.
Yeah.
Times what?
Pi 1 and P12
P12
plus
plus pi 2.
Pi 2 and
This time
P2 to 1.
is exactly. It should start from P21, right? It's going to be pi 2 times, right? So this subscript should be identical, right? First subscript of P matrix, the probability P should be identical to this subscript. Same, pi 2 times P21. Okay, the same here. This is pi 2 times P22, pi 1 times P11. Okay. So these are the customers who has only one car accident record, right, for any 2 years. Is that correct? Right? Here, the customer has the car accident in the first year, and then following year, there is no car accident record. Here, the customers who has no car accident record in the first year, and then following year, there is a car accident, right? So insurance company has to charge $300 for those customers, okay? So can you give me the number for this? How much we're going to have? So we're going to use actual value of pi's and p, right? Of course, p is from the original one-step transition probability matrix, p up here. And then we already got pi's from here. Okay, so I got $112.58. That's what I got. Okay. If I didn't make any error, then it should be the answer. Did you get the same answer? 5028? Oh, okay, so something, yeah, something like that. Okay, so does that make sense? Okay, so here, as the first step, defining the state of system was quite easy, right? But in this case, the last step for the computation of expected cost, you got to think a little bit more, okay? Because this part, I believe, is not that easy, okay? Okay, now let's think about another way to attack this example. So this time, I'd define 4 different states. Okay? So let me write down the state of the system first. So I do define first state is no accident. During, say, current and previous year. Okay? And then, let's say, state number 2 is accident during both current and previous year. and 3 is no accident. In current year, but there is an accident in previous year. Okay? Now you know how I'm going to define the fourth state, right? So it's going to be reversed, right? So there is an accident in current year, but there is no accident in previous year. Okay? Of course, we are assuming that at the end of each year, the policy holders will be determined to be in one of these 4 states. Okay? That is our assumption. Again, we are assuming that each transition takes 1 year. Okay? Like before. Now, using this 4 different state of system, let's see what transitions we're going to have. So here, 1, 2, and then 3 and 4. So let's start from state number 1. Okay, so let me use different color. So we start from state number 1. So what transitions do we have starting from state number 1? So where we can go from 1 to where? You got to be careful. Always stick to the state definition when you draw the transition line. Okay? Do we have this transition starting from 1, and then after 1 year, you can land in state number 1? Is it possible to do that? So basically, is no accident during the current year and previous year, and also next year, right? Is that correct? Right? So this transition occurs, right? So what probability is that?
1 minus 1.
I want you to go back to the problem description. What probability do we have here? I'm sorry, could you speak up? 0.97? Yeah, 0.97, right? Because here in the problem description, to say if he or she has not had an accident during the last year, there is only 3% chance of having an accident during the current year. So it's got to be 1 minus 0.03, right? Which is 0.97. And then what is this probability then? That is actually 0.03. Is that correct? So it does say, what is this? State number 4. That is the previous year, there is no accident, right? And then current year, there is an accident. Is that correct? Right? And then here, the state number 1 saying that no accident. Last year, previous year, and then no accident, the current year. So when you draw the transition line, you got to match this condition with this condition. Is that right? Then do we have this transition? What is this state number 2? State number 2 saying that previous year there is an accident. And then current year there is an accident. Since these two doesn't match, this transition never occurs. Is that right? What about this transition? 1, 2, 3. What is this? 3 means there is an accident previous year, right? But no accident current year. Again, this doesn't match, right? So this transition never occurs. Does that make sense? Right? Okay, so let me put this information here. So eventually we're gonna have this one-step transition probability matrix. Okay. So currently what we have is 1, 1 is 0.97, right? And then 1, 2 is 0, 1, 3 is 0. 1, 4 is 0.03. Okay, that's what we have currently. Now let's consider another case. So this one is no accident to no accident. Here we have no accident to accident, right? Here accident to no accident, and then accident to accident, right? Now we're going to start from state number 2. What transitions occur starting from state number 2? Do we have this transition 2 to 2? Is that right? What is this? According to the problem description, a customer who has had an accident during the last year has a 10% chance of having an accident during the current year, which is this, 0.1. And then, since these two match, we have this transition. Is that right? What is this? It's going to be 1 minus 0.1, which is 0.9. Is that right? So starting from 2, we have 0, and then 0.1, 0.9, and 0, right? Okay. Let me just use the same diagram. So we have state number 2. Now let's start from state number 3. What transitions occur? Because this and this match, right? So we have this transition. What is that? And also this and this match. So we have this transition. I believe this is going to be 0.97. So this is going to be 1 minus 0.97, which is 0.03. Okay? So we have 0.97, 0, 0, 0.03. Okay? Does that make sense? Right? Okay. Now let me delete this so we can use this diagram again. So now we start from state number 4. What transition do we have? Since these two match, right? So we're going to have this transition and these two match. So we're going to have this transition for sure, right? And then, what is this? This is 0.1. And then 0.9. Is that right? So these are actually same as this. These are exactly same. It's 0.0, no, it's 0, and then 0.1, 0.9, and then 0. Okay? So we have constructed one step or one stage transition probability matrix, P. So what is the next step? Like we did earlier, we're going to determine limiting probabilities distribution or steady state probability distribution. Okay? So let me delete this part. So again, we are going to use pi equals pi p and sum over i's pi i's equal to 1, right? So we have pi 1, pi 2, pi 3, pi 4 equals 1. And then pi 1 equals pi times the first column of this P matrix. So this is going to be 0.97 pi 1 plus pi 3, right? And then pi 2 is pi times second column of P matrix. So 0.1 times pi 2 pi 4. Likewise, pi 3 is 0.9 times pi 2 pi 4. And then pi 4 equals 0.03 pi 1 plus pi 3. Is that right? And because this system of linear equations are linearly dependent, I'm going to arbitrarily choose one. So I'm going to choose this because this is the most complicated one. So I'm going to take this out. And then I'm going to name it 1, 2, 3, and 4. Okay? And from here, if you move pi 2 to the left-hand side, then what do you have? You have 0.9 pi 2 equals 0.1 pi 4, right? If you multiply 10 on both sides, then we can simplify that, right? So it's going to be 9 pi 2 equals pi 4. So I can name it 2 prime, okay? And then I can rewrite down 1. That's going to be what is that? 1, 2, 3. So I'm going to use this. 1. Then what do we have? Pi 1 plus pi 2 plus pi 4 is 9 pi 2, so it's got to be 10 pi 2, right? Plus pi 3 equals 1. And convert this 1 prime. And then what about 3? It's going to be pi 3 equals what? It's 0.9 pi 2 plus 9 pi 2, right? So what do we have here? So this part is 10 pi 2, right? 10 pi 2 times 0.9 would be 9 pi 2, right? So we have pi 3 equals 9 pi 2. So let's say this is 3 prime. Likewise, 4 becomes 9 pi 2 equals 0.03 pi 1 plus pi 3. Is that right? Because pi 4 here is equal to 9 pi 2. That's why I have 9 pi 2. So I have 4 prime down here. So let me do this. So from 1 prime, which is here, we have pi 1 plus, it's going to be 19 pi 2 equals 1, right? So we have pi 1 equals 1 minus 19 pi 2. So let's say this is 1 double prime. And then what about 4 prime? 9 pi 2 equals 0.03 pi 1 plus, it's got to be 9 pi 2, right? So what do we have here? 9. Okay. I'm going to multiply 100 on both sides. So we have 900 pi 2 equals 3 pi 1 plus 27 pi 2. Okay. So I have 4 double prime down here. Then I'm going to rewrite down 4 double prime, which is 900 pi 2 equals 3 times Z 1 minus 19 pi 2 Is that right? Because pi 1 is this. Plus 27 pi 2. So from here, what do we have? 900 plus, is that 57, right? 3 times 19. And then minus 27 times pi 2 equals what? 3, right? Is that right? So here, pi 2 equals 3 over, what is this? 930, right? Can you give me this number? What is the value of 3 over 930? What is this value? Okay, is that 0.0032, right? Okay. Now we can get pi 1 because from 1 double prime, pi 1 equals 1 minus 19 times what? 3 over 930. That's going to be 330 minus 57, right? Over 930. What is this? It's 873, right? Over 930. What is this? Okay, I have 0.93. Is that 87, right? Okay. Let me know if I'm doing wrong. Okay. Now we can get pi 3, right? So from 3 prime, we have pi 3 equals 9 times pi 2. So it's 27 over 930. What is this? Okay, I do have 0.029. Is that right? And this is also same as pi 4. Okay. Finally, from 2 prime, we have 9 pi 2. So from here, pi 2 is pi 4 divided by 9, right? So what is this? Okay. Is that correct? I got 0.003222. Is that right? Okay. Actually, you know, we can determine the steady state probability distribution using Gauss-Jordan method. Have you heard about that, right? Gauss-Jordan method is very useful technique for solving the linear system of equation. I believe I've included that at the beginning of my 533 linear programming class. But actually, you can get that information if you do the Google search, okay, as well. So just recall your memory for the Gauss-Jordan method. Gauss-Jordan method. Okay. So we have four equations we considered, right? Which is here pi 2 equals 0.1 pi 2 plus pi 4, pi 3 0.9 pi 2 plus pi 4, pi 4 0.03 pi 1 plus pi 3. Okay? So from here, actually, this one, second formula, can be rearranged like this. 0 times pi 1, right? Plus, is that 0.9 pi 2. So what I did is I'm going to move the right hand side to the left hand side, okay? And then plus 0 pi 3 minus 0.1 pi 4 equals what? 0, right? Likewise, this equation becomes 0 pi 0, this time minus 0.9 pi 2 plus 0 pi 3 minus 0.9 pi 4 equals 0, right? Likewise, the last one, negative 0.03 pi 1 plus 0 pi 2 minus 0.03 pi 3 plus pi 4 equals 0. Is that right? So I'm still going to use the first formula here, first equation, pi 1, pi 2, pi 3, pi 4 equals 0. Okay? So I'm going to use these four equations. So what I'm going to do here is I'm going to have a big matrix. And then let's say this is pi 1 column, pi 2 column, pi 3 column, pi 4 column. And then I'm going to write a large vertical bar. And then I'm going to put the right-hand side values right here. Okay? So I'm going to take out the coefficient value and put it in this large matrix. So I have 1, 1, 1, 1, right, up here. So I have 1, 1, 1, 1, and then 0. Right? Next, I have 0, 0.9, 0, negative 0.1, and then 0 in order. So I'm going to put 0, 0.9, 0, negative 0.1, and then 0. So I just need to continue on this. Okay? So I have 0, negative 0.9, 0, negative 0.9, 0. I'm going to put 0, negative 0.9, 0, negative 0.9, and then 0. Okay? Finally, I have negative 0.03, 0, negative 0.03, and then is that 1? Okay, and then 0, like that. And then using the, elementary row operation, what you need to do is convert this side, left-hand side of this matrix into the identity matrix. right? Which is you have 1 on the diagonal, and off the diagonal you have all 0. Okay? Then you're going to get exactly the same value down here. Okay? That is, yes?
For the first equation, like the right-hand side, is it still 1?
Oh, yeah, yes, that's right. This is going to be 1. Okay, so that's the Gauss-Jordan method. So probably this would be easier, maybe. For the large size linear system of equation, this would be a lot easier. But the small size, probably you can just manually compute this. Okay. So anyway, we need to use all of these values, right? Pi 3, pi 4, this, pi 2, and then here, pi 1, right? We're going to use all of these 4 pi values to compute the expected premium value. Is that right? So, how'd you do that? So, this time, I want you to stick to the state definition that we defined. Okay? So we're going to stick to this. Let me delete this part. So in that case, how do you get the expected premium value? What is that? Of course, you're going to multiply $100. They're going to charge $100 to the customer who has no accident record for any 2 years, right? So, according to the state definition, that is going to be this, right? So you just need to multiply by pi 1. Is that right? That will be easy, right? How about $400? You're going to multiply by pi 2, right? How about $300?
Pi 3 multiplied.
Pi 3 plus pi 4. Is that right? Is that very easy, right? At this stage. So I believe you're going to have about the same value. What is that earlier? On $112 and 50 something. Okay? So you're going to have something very similar value, 50 something. Okay? So compare these two different approaches. First one, we go with two different states, right? Accident or not accident. And then we come up with this, expected cost. So I believe for the first approach, this part is not easy, right? But the second approach, defining the decision variable, defining the state of each state of the Markov chain system is difficult compared to the first approach, right? But this part is rather straightforward. It's easy, all right? So it's up to you. You can go either way. Either way should end up with the same result, okay? So this is a good practice, right? Okay, so any questions? Actually, this is all for today. And we're going to continue to talk about discrete time Markov chain the following class. Okay, thank you very much. And feel free to contact me if you have any questions. Okay.